Hello? Are we rolling? I can never tell. Yeah, looks like it. Okay. Well, welcome back. We are continuing where we left off last time with the drag reduction system for the Formula 1 spoiler. So I've been working with some different geometry for that, and I think we're close enough that we can move on. So let me show you what we're doing. So our goal here is to lift and lower the two these two rear airfoils with this actuator. So over a certain speed they will lay flat, reducing the amount of drag that the spoiler actually puts on the reducing the amount of drag that the spoiler puts on the vehicle so that it can hang on just a second, so that the I got a problem with my mic real quick. Okay, so what we're trying to do here is actuate these flaps so that at high speeds the spoiler doesn't create so much drag that it slows the car down in straightaways. Last time we were messing around with these linkages, and I believe we achieved something that's a good starting point. So we've got, with one actuator, we can move both of these, one from 0 to 30 degrees and one from 0 to 60 degrees. So what I'm going to actually do for the real one is replace this with a turnbuckle. Let's just look real quick. How much would one of those cost? Maybe not a turnbuckle, but actually a turnbuckle might work. So we're asking this to be 2.5 inches long. Clevis to clevis. Oh, the smallest they have is like 8 inches. Retracted length. Yeah, the one they have is 3 3/8. So we'll do, let's just keep working as if that's as if that is not, that is a turnbuckle. Okay. So we need to build a tab off of this boomerang piece that will hold this pivot point. So we already have the sketch started there with these 2 points. So we'll just convert this. We want to fix this one in space. Because otherwise it'll move around. So I like that at 0.25. That's pretty good. I do like that at about 1. Don't see why not. We'll make those equal. And then we will, this pivot point we decided is a 1032 clearance, which is 195, I believe. Yeah, I think so. Or 191. Let's add our fillets here. So we're just building up around the pivot point. We're using a lot of the geometry that's already there. Let's see if we can't just tag that into that. We'll fix this point here too. Since we're already using that, we'll make these 2 hole sizes equal. This part will be sheet metal. It's going to be a laser cut part from Send Cut Send. I wonder if Dylan can get them to sponsor this too. Then we wouldn't have to pay for anything, which would be awesome. But if not, I love using Send Cut Send. I actually have a pretty substantial order out with them right now. Oops. We'll make this tangent here. This guy tangent to that guy. And might as well do him equal to that. Okay, and then we got to go in here and trim parts that are not tabs. So then we can X out of here. We can select this sketch, select the base flange sketch or feature, and it will convert those to tabs. So boom, we've got a couple of tabs now that our flaps will pivot on. Oh gosh, that's so cool. That is so cool to me. So obviously we're going to need to add some notches and such, so that these don't interfere. That one's pretty major up at the top. If we cut that much out of it, I guess it'd just be the top side of it, right? Yeah, I guess it would. One thing, if I get the top 2 pivoting correctly and that all looks good, I might try to tie this bottom one into it as well. So if that were to be the case, the actuator might move. But for right now, look, I've got the actuator right here. It's tiny, you know, that's nothing. That cross section is not going to end the race. So where do we go from here? Okay, let's work on mounting this guy because I need, this part's are really complex up here, and I need to start off with a little bit of a win, something simpler. That looks really nice, you know, we're making good progress on that. So Dylan, I apologize. I haven't been full bore on this project like I thought I was going to be, but things happen. So let's build this section. Should that go flat too? Like, should we just make that a requirement? Because we almost could. Except I don't know how much force this actuator actually has. It's pretty good. It's pretty strong. But for now, let's just keep it simple with the top one. But let's go ahead and build a brace for mounting these two things together. That'll be easy. So what's the distance? Distance between those is 6 inches. I guess we could use more of that 5/16 rod. We're gonna have extra. I think I had to buy 6 footers and I only need 40 inches. So let's do a hole. Sorry, Mama. We are mixing metric and standard hardware. It's just what we do here in the United States. I happen to have a lot of M6, but the hardware store doesn't have metric hardware on hand, and what they do have is way overpriced. And ordering small quantities of metric hardware is ridiculously cost prohibitive, so we get to use what we have in the shop and use what the hardware store has. So we're going to use a where's the clearance? Screw clearance. One of my eyes is not working right today. 5/16. Boom. And then we want to turn on this and use that one. Beautiful. We'll throw the same holes in there. And what are we going to call this? The upper level support. Yeah, buddy. So now we just need to build some tubes. That's what we need. Just keep it simple. We need to keep rolling. That is exactly 3 inches. So, oh, we've got the clearance for the 3/16 already. We can just steal it from this part. Last night I watched Mickey 17, which I was really looking forward to based on the trailers, and the movie itself was kind of garbage, which was very disappointing. So I don't know what you guys are doing out there, Hollywood, but if you could be nicer, make better movies, I would appreciate it. Really disappointed. You know what I need? This should be a plug, and then we should put the aluminum tube over it. That would be dope. So, give me 1 second. Okay, so what we're gonna do is, oh shoot, this always happens. We're gonna take the inner diameter of this, which is supposed to be 5/8, but these tubes have been rather inconsistent. So if we do 0.65 minus 0.00125, then make this 3 inches long. This is the spacer for the rear. We'll take the mid plane of this, mate it to these two surfaces. we don't need this to be rotating, so we'll copy with mates. We will repeat the symmetric mate, and then the concentric mate will be here. Dunzo. We will hop down into the bottom and add these to our mirror feature, and now we've got a nifty little spacer. And we need to steal this tube. Is the inside of this actually 5/8? Yeah, it looks like it could be. So we'll do a configuration of this where it's shorter. Just distracting? This might be distracting. Oh, SolidWorks crashed. So give me 1 second here. My SolidWorks decided to take a poopy on me. But if you are just joining us, we are building a spoiler for an F1, a little F1 car. We're utilizing SolidWorks, and we will be 3D printing the spoiler when it's done. SolidWorks wants me to log in. It's having a hard time. So thank you. When your copyright protection makes it impossible for legitimate users to use your product, you know, you might want to revisit some things. I don't know much about software development and stuff like that, but your licensing interfering with productivity is a problem. Okay, let's see. By another user? I'm the only user on this machine. Oh my gosh. SolidWorks is such a mess. Now it's in read only. What the crap? Okay, SolidWorks is bugging out on me. So the rear spacer part worked. Let's see if the whole assembly got glitched out. Okay, so this should update with holes in it. I want holes in this part, and I want the tabs that the upper parts are pivoting on, and they didn't go. we lost a lot of progress on our... Let's see. Okay. Is it gonna work? She's thinking. Come on. Oh, it worked. It worked. Okay, I gotta grab something else real quick. Okay, I think we got it back. So SolidWorks took a dump on me right at the beginning of the stream, but I think we're gonna be good to go. So we have our center blade piece, and that's actuated by, we haven't figured out the actuator quite yet, but that'll lay those guys down. Login process has been canceled. Nice. I'm gonna save and reboot SolidWorks again. Guys, I am not a fan of all of the licensing bullcrap that SolidWorks has you go through nowadays. I understand people do, you know, they misuse SolidWorks. I will be the first to admit that when software is hard to acquire or it's expensive, you know, you mess around a little bit with the old freeware versions of things, but honestly, I am paying a subscription for SolidWorks and it doesn't work so often. It's really frustrating. I tried Onshape too, because it's browser based and all that stuff, and it really did seem like it was going to work better for me, but I am I used SolidWorks professionally for 8 years, and before that unprofessionally, I guess, and in those 8 years I got really good at it, I would say. And then I didn't use it for about 2 years, so I wouldn't say we're at my peak performance SolidWorks wise right now. But I tried to switch CAD programs because Onshape, I could access it anywhere. I didn't have to have my computer, and I just couldn't learn it fast enough, and it was really frustrating. So if SolidWorks keeps giving me grief, I may try Onshape again. Because when I used it, I could tell that the bones of it are pretty similar to SolidWorks. But the constant crashes and the stupid login, and then the fact that whatever SolidWorks experience or whatever, the online version of it is just so stupid and annoying. It doesn't work like real SolidWorks. That has got me about ready to bail. But I have a lot of projects that I just need CAD for, and I already know SolidWorks, so it's really hard for me to justify learning a new CAD software when I just need it to work for right now. So, okay, what we're doing now, okay, sorry, that was a lot of complaining. These braces are going to be 3D printed. We'll make these out of plastic. So let's just set that to, I guess we'll set it to ABS. No, I don't want it clear. We're gonna edit the material here, plastics, and we're gonna do PETG, PE, high density, low density. We'll do that. Perfect, and it's even the right color. So we're gonna use this as a spacer within the tube here. So what I've just done is I've borrowed the aluminum tube out of the brace, and we made a configuration. We're gonna call it rear brace, and we're gonna go down into the core geometry, and we're gonna for a specific configuration. OBS doesn't show all the little windows that pop up with SolidWorks, but we're going to change this dimension to 3 inches for only this configuration. And then we can take our tube, bring it in. We can change it to the rear brace configuration, and it'll be shorter, but we don't have to redraw the whole thing. So we'll make it concentric with this. We'll make the right plane concentric with, or coincident with the other right plane. And lock that rotation down. And we'll copy this with the mates. We will repeat no, we don't want to repeat any of those mates. So we'll do that. And then we want the right plane off the spacer. And we are good to go. So we have, now we can thread a bolt all the way through this. We'll have a plastic spacer, but there'll be no exposed plastic. These will be aluminum bars on the back. I think that'll look really nice. And like I said, a lot of this is aesthetics. We're trying to make something look cool just as much as we're making it functional. So if you weren't here last time, we've already finished the bottom, made it into an assembly. I've printed this out already actually, and test fit it with the tubes and the threaded rod in PLA, and that's working really well. I am going to use PETG carbon fiber to print the final version, and I need to do some test prints with that. But until that happens, what in the world? Is this not centered? How is this mounted? Oh, it's fixed. Oops. So we don't actually have a right plane mate on that. That makes sense. So what are we mad about? Well, just watch me explode my entire assembly as I try to add mates to it. Apparently, it's angry. I have made a mistake. Let's see if we can make these. Okay, perfect. That should shore some things up. Okay, so our spacers are no longer going to be 3 inches. They're going to be 290. What is 93? 9375. Is that 15/16? Yeah, it is. I know fractions. God bless America and the imperial measuring systems. Okay, so this is what we got done last time, and what I'm really proud of, what I think is going to work well. We've got our single linkage, and we just got to play around a little bit with the distances here, but we'll be able to actuate the lower one, 0 to 30, and the upper one 0 to 60 with one rod, and just make it a little bit adjustable, and we'll get it going. So I needed to make these parts work. Little quick win there, something that had to happen so that we could get it finished. Okay, I think that looks pretty sick. Let's change the mate on this bolt here, because I don't like that it is within the other part here. Okay, so we got our cool bolts going on. Copy with mates. We'll add that to here. We'll repeat that one. And I gotta go. My Walmart grocery delivery just got here, so I wasn't planning that. Give me one little minutes. All right, sorry about that, but such is life with these things, you know. And after all that, they forgot my milk. What a bummer. So we copied the hardware up here. Let's, oh, we don't have the hardware mirrored over, do we? That's okay. I guess I did order milk and they didn't get it. We'll work on that later. So let's add a hole for this one to pivot. We don't have any of the holes for the I don't want to add holes to the side plates just yet. Because those holes will keep moving around. They'll change levels of the assembly and stuff, and it could just cause a crash, which SolidWorks is already really good at. Okay, what are we looking at? We got these nice spacers here. So this is bolted to the chassis. These things are coming up. They're spaced apart by the wing itself and these tubular members, which is dope. Then this is held in place. I guess we could start working on how this interfaces with that. I am so tempted to just make these two pieces slide together in front of that, but I think that it would be more beneficial if this was solid across there, so it didn't have a center seam, you know what I mean? So if we look at this, we need, ooh, why is that moving? Whoa. So why is this moving, and how can we constrain it better? Why isn't this fully constrained? it's not constrained to this. And the weld plate. What did I not do right here? Can I fix the weld plate in place? Oh my gosh. Things that were working just a minute ago have stopped working. But anyway, so we got this going on. We need to make this actuator into an assembly. Oh, it is an assembly. Did he already make it? Oh, it just spins. That's not what I want. We're gonna take the actuator here and apply some limits to it so that we can properly simulate the motion of the DRS flaps. So I'm looking up the specs on the actuator real quick, and the one that I got is retracted length 85 mil, extended length 115. Okay, so let's go ahead and add those dimensions to our model here. So she thinks that she's fully oops, we want to make that a mechanical mate. Not a mechanical mate, a limit mate. So we'll have 81. Let's pull up a calculator. So that'd be 115 minus 85 is 30. Plus 81.9 is 111.9. Messed that all the way up. Okay, so now we should be able to move this. Yeah, and it does what it's supposed to do. It actuates. We save that. Go back to our assembly here. So we need to move we could almost just do something like that. Watch. Just for the sake of making this go a little bit quicker. Where's my actuator? The actuator came with some like clevis pieces, but we'll figure that out in a second. And if we hop into our boomerang section here, we go to that tab that we added. This tab. We can add whatever that's going to be. we'll do a tangent arc off of this, a tangent arc off that, a tangent arc this way. Make those concentric, and then we'll make these equal to the other ones. Keeps picking up that point instead of the line. Okay. Boom. And we'll mount this here. Boom. But then we have to make this flexible. Here's where the magic happens. Oh yeah. So what is the distance between these two holes? So earlier when I was trying to measure stuff, I kept hitting the wrong things, and that's why none of that was being very happy. 3.9 inches. Which is nine. We have another centimeter to go. 99. So I wonder if we move that from this one. What if we move it up to this one? Yeah, and so what that's going to do is give the actuator a little bit more chance because it's got a longer lever arm. Yeah, buddy. It's looking pretty good. And I guess we'll make a cool little fairing for it, but honestly, it's just so small. Do we even care? Do we even care? IP54. What is an IP54 rating? IP54 is pretty good. It's pretty high, isn't it? 5 is dust protection, limited ingress will not interfere with operation of the equipment. Okay, and 4 is protect against water splash from all directions, limited ingress. Okay, so it doesn't need a fairing. It can just chill out there in the elements and it'll be happy. That's pretty chill. That looks sick. I'm really happy with that. Oh, but does it go down far enough? Yes. This one needs to come down further. Which is just some geometry tweaks. But we're getting a lot of the big bugs worked out. We need to fix some mates, so bear with me. We're gonna do some exploratory surgery. So this plate is allowed to move up and down, which is not something we want. So is it this the mate that we need? So that guy's fixed now. That guy's fixed now. But the top cross member is not happy. So why is that? This distance. It's all angry. Suppressed face. Oh shoot, I know what happened. I suppressed the side instead of just changing the opacity. My bad. Okay, everything's back to normal. So we hide this now. Hide, don't suppress. Suppressing takes away all the mates. Let's change the music up a little bit. Okay. Everything went back to normal there. Yes. Yeah. Okay. So cool. So cool. So when you're just cruising around the track, nice and slow. Hang on, does that not move up as much as it used to? No, I think that's right. And then you hit the gas, wide open throttle, and the air just goes right through it. Beautiful. We need to actually figure out this linkage, I think. That's bothering me. So, if I'm thinking correctly, we're complete here. This piece is complete. This lower assembly is complete. So, we've got more done than not done. Let me look for that actuator came with a bunch of bits and bobs. Bits and bobs that I seem to have misplaced. Okay, so the actuator came with little brackets like this, which would let you mount it to the surface of things. So on the top, on the spoiler there, that might actually be pretty useful, except I would just print that into the part as a feature. On the bottom, we're gonna have to come up with something different. So do we make a mount for that now? Is that where we're at? Or do we just put it off to the side? No, that's lazy. So let's build a mount for the actuator. And what I have in mind is an H shape. So we'll have the thickness of the upright, and the thickness of the actuator. So the thickness of the actuator is 0.31, and I know that the upright is 0.1 eighth of an inch. We will have, this doesn't need to be as thick, so we can turn off the vertical alignment there. We will make these equal to each other, and then I think I don't like the way that that looks. We'll go like this. We'll make these equal to each other too. The actuator 34, so we'll just do 0.375. How much engagement do we want on the, do half an inch there maybe? Okay, seems reasonable. There really doesn't need to be a big gap between there, so let's just make that, I like 1875. Let's just make the center of it the center of the part. Boom, everything's black. We will use the front plane. I guess we could have used that construction line. We'll mirror that over, and then we'll extrude that for what feels right. Ugh. 1.5 inches to the midplane. Then we'll turn on our see-through settings. We're gonna do a right plane cut. We're gonna draw out. Wait, hang on. Do I care about that right now? You know what? Let's just leave that. We will leave some adjustment in this. So we'll do this as the actuator mount. And then we can add some fillets. Actually, they need to be chamfers because of printing. So we'll drop that down to an 1/8. How's that look? Does that look okay? Let's give it some more. 250 seems reasonable. We'll fillet these top edges, because I envision this part printing on the end so that there's no overhangs. Dylan, I'm trying to make it easy on you. I don't think he has a 3D printer or has used one. Maybe he has. So that's not too bad. It'll print like this, vertical. And that way the overhang here is as minimal as possible. And we can add some holes in this. And the hole is in the actuator is 0.16. I don't know what 0.16 is. Oh, did I have the actuator pulled up still? I think I did. Let's look. There's usually a really detailed spec sheet. But this time there's not. But what we're gonna do is we'll linear pattern that 3 times. We'll make the center one even with the top here. We'll spread them out. We'll make a safety zone with this construction geometry. Set the height on that. So the safety area 3, 4. I think it's dead center actually. We'll see in practice. Because if it's centered, all we gotta do is one of these. Make that a construction. Let's make this a let's just make it even with the edge of that. And on the bottom side here, we will use 2 screws to attach it. We'll just use the same number 10s that we have been using. And we're here, and here, and here, and here, and here, and there. Does it seem right? Okay. Kind of chunky. Might need to adjust that a little bit. But what that lets us do, we're gonna actually go back into this tab feature and delete it. Boop. Yes, I know that I broke the mate. We're gonna insert our actuator mount here. We can right plane mate that. Well, I guess it's the front plane in this part to the right plane. We should center it up. We will use the top edge of this channel to mount to the plate. Dope. And okay. This is changing my plan a little bit, but not too bad. Make these 2 things concentric. We tell this to be a certain distance from, let's just use this point right here. What do we want that to be? 2.5? Alrighty, so let's go back in and change this. I'm not a big fan of the way that that turned out. So we're just gonna do it this, and this will make sense in just a moment. We are not going to chamfer. We're not going to chamfer anything. We're going to do a profile cut from the side. So these boys are we could do the same thing. I guess if they have the same size hole, they can just be vertical to each other, right? This to the bottom edge there. Okay. Then we'll use a right plane or front plane cut. I'll go ahead and make that concentric to that guy, tangent to these guys, and that will cut that front lip off, going all the way down to the very edge. We'll put that in there. We'll get rid of that actually. We'll make that come to the very edge. Okay, so that'll cut all that off. And from the bottom side, we want something similar, but we need to start it with a chamfer. So make those tangent, make that concentric. While I'm doing this, I'm thinking about overhangs for prints. We want 30 degrees or less overhang, and the closer we can get to 30, the prettier things look to me. So we just have that. Why do because 30 degrees, or the chamfer will ensure that there's no, man, what does he keep doing that for? I guess that's the way it's got to be. Okay, well, in that case, we don't even have to start it at 30 degrees because the part doesn't start that way. So we can trim off all that crap and then just mirror it across for fun, I guess. Wait, why does that work up there but it doesn't work down there? It's because these holes are not in the same place. Okay, and then it didn't like this being one line, because then there's two profile, or it's two areas with one profile. Boom, there we go, that's what I want. Okay, but So instead of that at all, we're gonna do this is even with that, and it has the same of all that, and then this sketch. Now, unfortunately, we got to redo all this. But it will do what I said initially. We have to start the part with a chamfer, and then we can go into a radius. That's what I'm talking about right there. We have to do that, or you get a nasty, the fillet just doesn't print well. So then we come into our flat section and we make it our 30 degrees. And now when this part prints on its end, the first little part of this fillet is going to be flat, unfortunately, but it will be consistent. It won't have ugly squigglies. So then we take a look back at our nice. We're gonna suppress that. That's fine. We're gonna flip this one. We're gonna unsuppress that. We're going to flip that one. Then we're going to mount this to this hole, and that's it. What a mess. Okay, so does this still work? Yes, but it's too far up, so we need to move this down just a hair. So 2 point. So when that's all the way retracted, what is the top plane? Is still not flat, so we need to move it down some more. Top plane of that is evaluate measure, should be parallel. Yeah, and it is. So this actuator now pushes this bottom one in an arc, and the top plane to the top plane there is 27 degrees. So did we max out our actuator? Is that what's stopping us? No, we're hitting the max of this guy. So if we suppress some mates on the linkage, just one, we should get our full 30 degrees out of that. So I'm gonna call that like design accomplished on the geometry between the actuator and the lower dealy bopper here. Love it. Beautiful. So this is moving. That's fine. This needs to move, and we need to figure that out. So if we pull that down and we push it up, let's use a different hole. Let's try this one or this one. Center to center is 2 1/8. So we don't even need the actuator. Let's just mate those. Distance wise. Perfect. So when this goes up, that goes up. Oh my gosh, it's so close. Is that close enough? Is that close enough that we just don't care? Do we get our 30 out of this one? I think we do. We get the full 30 out of the bottom one, right? Yeah, we do. Oh my goodness, that's so close. And then this one, what are we at? 53, we're missing 7 degrees. What can we do? If we wanted to push that up ever so slightly more. Oh, that's a lot of trig. Man, it looks so good. I say we just go with that, to be honest. So what did we say that was? 2.125. So we have this hole to this hole. Hope that doesn't cause any problems. We'll have to check that out in a sec. And let's get rid of that distance there. We'll get this one and this one matered up. Yeah, that's pretty dope. I think we're gonna leave that. But what I want to try, just for giggles and shins, I want to see what happens if we move this closer. That wasn't that much closer. How long have we been doing this? An hour and a half? Let's go 30 minutes more. I got 30 minutes. I think we should not have this actuated on the same pivot. We should have it pushed off the top. That might help us out a little bit. So if we measure the distance between those two holes, we get 1.5 inches, which works for me. This is gonna break something because I didn't unmade it originally. She's not happy. Come in here, we delete that mate there. We put her up to this one. And now, oof, that didn't work. Didn't work good. We need it to move some more, so what's the distance between that hole and the upper one? 1.16. Take it out of this hole. I know we just had it figured out, but this is gonna be better. That way. Okay. I don't know about that. That linkage doesn't look quite right when it does that. Looks like it goes over center, which means it could jam, which is not something that we want. So first of all, we've still got to we're gonna have to break that linear pattern in that sketch. We're gonna delete all, oh no, we're not gonna delete all the rest of the holes. We need this to be a little bit further down. And back. And we can at least remove that one because we know we're not using it. Get this bottom part figured out. Back's starting to hurt. That's when you know it's time to get off the computer. We got our two geometries in there. We'll open up that part. this other geometry. This one is for to give us clearance for the pivot. So we want some of this. We want it to come up to there. We're going to make these even one as well. And then I don't want to go below center of the circle because I think that would be ugly. What does half an inch do? I think that'll be okay. Unless it goes past, it does not. I'll trim the end of the situations here. Apparently it doesn't want to be equal. Friend over here. Guess that's fine now. I didn't like it before. Maybe it doesn't want to be equal. What is that all about? Just leave it at 0.5. That's weird. We're gonna extrude this guy. We're gonna do offset from the mid plane. What's a good thickness for that so it doesn't break off? Our good old 3/16. We're gonna mirror that across to the other side. And now go back to the assembly here and we should have, yeah, there you go. Dope. We have a mount built into it. So we've got the actuator mounted top and bottom, and it pivots without interfering. So the goal now is to figure out how to move this upper section here without messing around with this too much. When this is up, and this is up. Let's try this hole to this one. Oh, that's not that bad. Okay, well in that case, which one did we use? The front one, inch 1.27. What is 1.27 close to? 3125 minus 0.065. 1.27 is close to 1.28. So then we can undo that suppression of that mate. We can get rid of that distance. That's pretty weird. I don't like that a lot, actually. Again, we've got that problem where it feels like it's going over center. Right there, it goes over center, and that's not good. We don't want that. So one way to prevent that is to move this point further backwards. So we can start to, let's just dimension this. That way it's black. So that one's done. Then we can do some dimensions like this. You know what? I don't think that linkage should be aluminum anymore. I think that we could do a little H bracket for that too. I have a good idea for that. So this one flat and that one flat. We mate. These distances. And now it just moves straight up. And it goes the entire way. But do we get our full range out of this one? I don't think so. That doesn't look right. So it's moving too much. So let's try the rear one. Or did we already do the rear one? It's about time for some eye medicine. Oh, we didn't do the rear one. Let's try the rear one. So with that flat and with that flat, we're going to try that. And now this moves up. What's stopping us? Is it this limit? Yeah, it was. Okay. That's it. That's it right there. So let's drop a bracket real quick, get that going, and I think we're golden. So that distance is what the length of the bracket's going to be, which is 2 1/8. they can't get to 2 1/8 in the current situation. Is that because, why is that? This thing not flat? That thing's not flat. So, do we move this down a hair? You know what? It is so close. It is so close. We're gonna call it. How long is this thing? How is that? Oh shoot, I did it again. I made it the wrong things. Crap. We need to mate. This thing's messed me up. We need to mate from this one to this one. We're not very well using this whole. That works. Okay, so we come in here. What's the only one without we add some real dimensions to this. And then, so this is the lower one. So we want to make, do I want to make essentially the same tabs, top and bottom on this piece? Would that make printing it easier? We're gonna have to split this kind of right down the middle. Yeah, I think making this one have the female bracketry is gonna make our lives easier. So we'll convert this entity. We will convert this entity. We will add a arc around that. We'll make them concentric. We will add equals to that. Oh my gosh, why is it so mad about everything? It's just mad. This piece. So should that just be flat? Can be. Okay, no. Okay, so we've got this all set up. This will be our lower DRS flap configuration. We will add a configuration to an upper DRS flap. We will suppress this extrusion, and we need to pick up this point. We can show the sketch though. We need to pick up this point in our upper situation. We will add an arc. We'll make it concentric to this. Whoa. I'm losing my eyes. It is going to be time to put this up for the night. We want it to look about like the other one does, because that looks cool. Okay. And then to move this, we will do a mid-plane. And we need to make sure in the other configuration that front part, yeah. So we have an upper and a lower. We'll hide this sketchy, we'll hide this other sketch. We'll go into our wing part. We change this to the upper config. So now it's only got the upper features. We get our DRS linkage. Oh, no. Let me show you from the back. What is this distance? 25. We use 25 here. So we come back into our actuator linkage, right? Oops. Give me one sec. We're going to check the distance here, which is 625. So we're not going to do a base flange anymore. We are not going to do sheet metal anymore. We are going to use this sketch to make an H-bar linkage. So that is 625. Boom. Then we want to remove on the top. We want to remove the middle. Oh. For, I don't know, that much. No, that's the wrong thing. We're not doing the right thing here. We need to invert that. We're just gonna delete all that. Boom. We're gonna go like this. Bring this up to here. And do that. And the distance between these is whatever we want. Actually, we don't want that distance. We want the distance between this and that edge. Then we're going to go over to the liters. We're going to do a minimum and a minimum. And then we can make that something like that. We do an extrude cut from the mid plane. 0.25 plus 0.0125. Then on the bottom side, we kind of do the exact opposite, right? So, wait. We can do it from here. We convert all these entities. We mirror them across. We make these for construction only. Now, we take this, we go offset 0.125 and then through all the other way, and we take that and the right plane, mirror that dude, and we have our little H-bar linkage. So we need to clean this up for 3D printing. That is not a suitable 3D printing part, but check that out. Pretty freaking slick, man. So we come in here. Oops, not that face. Not that face, please. This face, please. Man, whoever just hopped off the stream, you're missing the best part. We are about to kill this thing. It's looking so sick. .27. How long did we make this? Boom. Yeah, buddy. That's awesome. Oh, yeah. Let's go in here real quick. Change a bunch of these materials to the actual materials that we're going to use or close to. PE, low, medium density. Okay. All right, so walking through this real quick. These plates weld to the chassis, and they're steel, so that should be pretty easy. Then we have one bolt right through the middle, so the entire wing can rock back and forth just enough to level it out with these slots. These go up through the lower assembly, which has an aluminum tube. It's compressed by a threaded rod on both sides and a flat solid rod on the back that keys together, so it makes it really rigid. There isn't any racking in the test print, which is great. We have countersunk bolts that meet with nuts that are inside, so the assembly is really streamlined and flush. This lower cross member here, I haven't made it adjustable yet, but this one will be adjustable on the outside with a half moon. The upper cross member here will have the same features as the lower one, with the aluminum tube, the threaded rod, and the bolts. It'll be split just like this one is, so that it can be printed. These are going to be aluminum plates, 1/4 inch, that I'll send off for and have laser cut from Send Cut Send. They are sandwiched in with this bottom cross member, and then another short section of aluminum tube with a 3D printed spacer in it, which will make for a pretty strong H-bridge type of construction to hold the center beam here, which will stabilize the center of the top cross member as the bars pass through it as well. Then we've got our DRS system, which is this actuator I've already got on hand. At a certain speed, we could do it with GPS, or we could do it with a button. I already have the stuff to do the GPS if that's what you want to do. Then it would just work off speed. It'll pull down and flatten these guys out. And then when it extends again, you've got your full drag situation going on. So I'm really proud of the way it's coming out. If you're liking this project, let me know if we want to do something a little bit different. If there's a piece of it that you're not in love with, give me a shout and we will change it up. But as far as design goes, all the hard parts I'd say are done. Proved out the concept that we can print something like this on the bottom here, and I just need to spend a day, copy these types of features to all the other long members so that they can fit on the bamboo printers. Obviously add some clearances where we need them, and then I want to put together a full bill of materials so that I can make a drawing package, so when it arrives you guys can put it together like a Lego kit, where it's just step by step and there's no guesswork. But anyway, sorry this is taking so long. I saw that you guys are at Slush Fest, and that looks like a blast. But hopefully this is aligning with your vision, and we can make this happen. So let me know. All right, so okay, so that last little bit there was for Dylan. I screen recorded the assembly I went through a little bit of the features, and I think I'm really starting to love the way that this is coming out. It's one of those things like you had a clear vision, you get into it, and suddenly things are not working exactly as you expected. So you get a little bit discouraged, but that's okay. You push through, come back, and now I'm really stoked about this. I think the action that we've got on the, let me put this back on here. The action that we've got on the DRS system, DRS without system, because that's redundant, is pretty sick looking in and of itself. Even if it doesn't do much, that's really awesome. So I'm really excited to move forward with this. I hope that the guys over at the Red Factory are loving this as much as I am, and they have some positive feedback. So that's gonna have to be it for tonight for the stream. What did we do? Just over 2 hours, which is a lot of time to spend sitting down staring at a computer. I used to sit 10 hours a day at a computer, and did not do good things for my eyes or my back. And now I remember why I kind of left that world behind. But I love doing this kind of stuff. So if you're into crazy 3D printed projects, CAD, you know, just muddling through the design process, go ahead and drop a like and subscribe on the channel. This is what I do all the time. I would be doing this even if I wasn't streaming. So I just decided to turn the camera on one day, and hopefully it takes off, and this is something that I can do in the future. You know, long term, I would love to design crazy parts for people constantly and manufacture them at home. I have a full suite of manufacturing equipment at home to do these weird prototypes. So you know, hopefully one day it kicks off. So if you're watching this, you are an early adopter of my dream. So thank you very much. Have a nice night. I'm gonna have to turn it off here, but I just want to look at this one more time. So what I've done, I've created the drag reduction system with this little actuator, and as it moves down, it pulls those two vanes into parallel with the other two vanes, which should allow for a huge reduction in drag going on high speeds. And like I said, we proved out the 3D printing concept along the bottom section. So I just need to, I've already printed out the bottom section in PLA. I'm gonna print it in PETG carbon fiber, and I need to, as far as the CAD goes, I need to adopt the sectioning that'll allow us to print it on the Bamboo Labs to all of the other cross members, and then work on some features for the side plates, the holes on those panels. But we're moving right along. So I did a little screen record of all the features of the wing earlier, and I'm gonna send that off to Dylan at the Rad Factory. Make sure we're going in the right direction. But yeah, man, this thing is sick. I hope he chooses the GPS option, because I was just getting into coding with ESP32, and I have these GPS modules I wanted to try. So what would happen is at a certain speed it would actuate on its own, and then when you slow down it would restore itself to that position. So anyway, thank you very much for tuning in, doing these crazy projects all the time. Have a good night.